Okay, this is lesson 1.5 for Mr. Kennedy's Math 10C class. This is a flipped classroom class, meaning that you need to watch this video at home or on your own time while filling out the notes. Okay, so today what we're going to learn is we're going to learn about 6 exponent laws. But before we can learn the exponent laws, we need to just remind ourselves some of the terminology. So here you see the entire question here, we refer to that as a power. And every power is made up of two things, the base and the exponent. The base is the main piece that you see in the inside. It's written in bigger letters. And the exponent is written with small letters. And it's up here in the top right of the base. So if we look at our example below, it says state the base, the exponent, and the coefficient. So we will state the base as AB. And that's the base because it's the big written part. It's inside the brackets. And you see the exponent, 4, is outside the brackets. Now it also says you need to name the coefficient, so that's just a review. The coefficient is anything that's multiplied on the outside of something. So right here, our coefficient is -2. Something important to note about the coefficient is it does not get affected by the exponent of 4. All right, we move on. We're going to look at our first law. Our first exponent law is the zero exponent law. And what this law tells us is that anything to the power of 0 is 1. So we have some examples here. -6 to the power of 0, because of the exponent law, that means it's 1. We look at part B. Our base is -9 because the -9 is inside the brackets. -9 to the power of 0, using our zero exponent law, is 1. If we look at question C, we notice that the base is actually only the 9. So just this portion is the base. The negative symbol is actually a coefficient. So -9 to the power of 0 is equal to -1, because that coefficient is not affected by the exponent 0. All right, we move on to law 2. Law 2 is the product law. And the product law states that if two bases are the same and they are multiplied together, the exponents can be added. So we look at a couple examples here. We notice that the bases are the exact same. They're both b. Because the base is the same, you can add the exponent. So we would write this as b to the power of 7. You could put the b in brackets if you want, but it's really not necessary here, as b is the base and there's no coefficient in front of it. We look at question B. We see two bases are the same, x and x, which means we can add the exponents. Don't forget that that second x has an exponent of 1. You just can't see it. So when you add those together, it's x to the power of 7, because 6 plus 1 is 7. Let's move on to law 3, which is the quotient law. Quotient, remember, just basically means division. So using the quotient law or the division law, that tells us if the bases are the same, the exponents can subtract. So here we have the bases are both x, so you can subtract the exponents to get x to the power of 3. And that's because 6 minus 3 equals 3. For B, we see if we have the same base. They're both AB, which means you can subtract the exponents. 5 minus 2 is AB. B, and here the brackets are important because we want both the A and the B to be part of the base. To the power of 3, because 5 minus 2 is equal to 3. Law 4, the power of a product law. So this means a product means multiply. So they're saying the power when you have a product as the base. So we look at A, and we see that we have ST as the base, and it's to the power of 6. Our power of a product law says that that 6 can come into the brackets to both things because they're multiplied. And it becomes S to the power of 6, T to the power of 6. We come over here to question B, and we use our power of a product law. So here we have a negative, a 3, a P, and a Q as the base. So that 4 needs to go to all those things. That negative symbol really means -1. We're just lazy in math and we don't write the 1. So notice that I put 4 lines there because -1 to the power of 4 is something you're going to want to calculate. So when we bring that 4 in, we have -1 to the power of 4 times 3 to the power of 4 times P to the power of 4 times Q to the power of 4. We don't leave our answer like that because we want to evaluate it. So the -1 to the power of 4, if you do that in your calculator, make sure you use brackets because you want -1 to be the base. If you don't put brackets in your calculator, it won't work for you. When you put -1 to the power of 4, you realize that it's just +1. 3 to the power of 4 is 81. And the P to the power of 4 and the Q to the power of 4 stay the same. You then can combine the 1 and the 81. You multiply them together, which just gives you 81. So we're just going to erase that one. That's silly to write it. The important part is realizing that -1 to the power of 4 gets rid of the negative symbol. We move on to our 5th law, which is power of a quotient law. This works the exact same way as power of a product law in that an exponent can come inside the brackets to all of the items in the base that are being divided. So this would simplify to be x to the power of 9 divided by y to the power of 9. Looking at part B, we do the same thing. That 2 goes to both places. And 4 squared can be simplified to be 16. When we have numbers that can be simplified, we always want to simplify them. Power of a power law. So this refers to when your base already is a power. So if we look at question A, we notice that A to the power of 4 is actually a base for the exponent 3. When you get this law, you get to multiply your exponents together. So that 3 comes in, and it becomes A to the power of 4 times 3, which is just A to the power of 12. Do the same thing for part B. So the 5 comes in, and it becomes x to the power of 10. Finally, we're going to do a couple slides on combining laws. So this is where you have multiple laws together. Here you look and you see question A, we have a whole bunch of laws that can actually take place. The first one we're going to focus on is I'm going to try to simplify the top of our division statement and the bottom of our division statement separately. To do that, we use our product law, knowing that x to the power of 3 times x to the power of 5 gives us x to the power of 8 on the top. We get that by adding the exponents. That's the power of a product law, one of the first ones we learned. On the bottom, we do the same thing. Don't forget that that exponent is actually a 1. It's just not there because we don't write exponents 1. And it simplifies the x to the power of 3. We now can use our quotient law, which allows us to subtract our exponents, leaving us with x to the power of 5. Because 8 minus 3 is 5. For B, we're going to follow the simple rules of BEDMAS here, because that will always lead us to the right answer. The very first thing you're going to do is you're going to see if you can simplify anything inside the brackets, and you realize you can't. The second thing you do is you move on to your exponents, and we notice that this 5ab squared is a base to the power of 2. We call that a power of a power law. It's also going to be a product of a power law. So the first step we want to do is we want to move that 2 into everything, including the 5. So we now have 5 squared, a squared, b to the power of 12, and that is times 4a squared b. We now can continue with BEDMAS because we have dealt with our exponent. We get to division, there's no division. We get to multiplication, and we see that we can start combining some things. So our numbers are the first things we're going to deal with, our coefficients. 5 squared times 4, those can be combined. So 5 squared times 4 will give you 100. We then move on to our next ones, and we say our like bases. So we have a like base here and a like base here. Those can be combined by adding the exponents. So that becomes a to the power of 4. We then move on to our next like base that we see. And we have b and b. So those exponents can be combined to give us b to the power of 13. And that's our final answer. Some more combining laws, a little bit tricky, a little more difficult. So we look at this. Again, I always want to simplify the top and the bottom separate and just deal with those, but we have to do that by following BEDMAS. So the exponents need to come in to the brackets on both the top and the bottom. So we simplify that to be 16. When that squared comes in, we multiply it to the other exponents because power of a power law. So 2 times 3 gives us x to the power of 6. So 5 times 2 gives us y to the power of 10. And it's divided by 2 to the power of 3 is 8. I can punch that in my calculator. And x to the power of 2 times 3 is x to the power of 6. Now that we've simplified the top and we've simplified the bottom, we check to see if we can combine anything. The very first thing we always deal with is our coefficients. And we want to try in our calculators 16 divided by 8. If you punch in your calculator, you'll see it actually simplifies to be 2. And that 2 goes on the top. We then move on and we look for any like bases. We notice that we have a like base here and a like base here. Those can be combined to be x to the power of 0. Because 6 minus 6 is 0. And the y, you'll notice, does not have a like base on the bottom, so it can't be combined with anything any further. We then use our 0 law to remind ourselves that anything to the power of 0 is 1. So this x to the power of 0 we see there is actually just equal to 1, which means we can basically cross it out. And we are left with 2y to the power of 10. The reason we basically cross it out is because 2 times 1 is just 2. Right, we'll try D here. The very first thing you want to deal with, again, is your inside the brackets. So you want to see if you can simplify anything inside the brackets before you actually bring that exponent of 4 in. So we're going to leave this 4 to the very end because you want to deal with inside the brackets first. On the top, the 4 and the 3 can be multiplied together to be 12. And you notice the x and the y can't have anything done with it. I'm changing the order to alphabetical, but you could have written it y to the power 3 and then x to the power 6, and that'd be okay. On the bottom, we have 6x to the power 5. Up to this point, we've only multiplied our numbers on the top. We then see if we can simplify the top any further, and we notice we can't. The bottom, it can't be simplified any further either. So now we try to combine the tops and the bottoms. The 12 divided by 6. If you put that in your calculator, you get 2. Again, it's still in the brackets, and the 2 goes on top. X to the power of 6 and x to the power of 5. Those can be combined using our quotient law. Because it's division, you subtract the exponents. So it will be x. Because 6 minus 5 is 1. We don't write the exponent 1 because that's just silly. The y to the power 3, it can't have anything done to it. And this is all still to the power of 12. Now that you've simplified everything in the brackets, you see it's not so hard to bring that 4 in. So we're going to use our power law to bring that 4 in. And you have to bring it to all 3 items of the base. So it becomes 2 to the power of 4, which is just 16. And then x to the power of 4, because 4 times 1 is 4. And then it becomes y to the power of 12, because 3 times 4, the exponents multiplied, is equal to 12. And that's your final answer. This page is just a formula sheet that shows you all of the powers, all of the laws that we learned, except for the zero law. So the zero law is not on your formula sheet. The rest are all here: product law, quotient law, power of a product law, power of a quotient law, power of a power law, and an example for each one is there. This is a great reference guide, as well as the examples we've done up until now.